So in today's example, we'll see the first function which we are going to see is the reciprocal function. It returns the reciprocal of argument element wise. So for element with absolute value larger than 1, the result will, as you know, will be always 0. Because of the way in which your Python handles the integer division. So for 0, if you have a 0 as an element, there will be an error or warning of overflow, okay, especially for your reciprocal. Let us take one small example. So I will input numpy as np. We'll create an array a equal to np dot array round bracket, and we'll put some values here, say 0.25, 1.33. Let's put a constant value 1 with integer value 1. Then let's put 0 as well to show you the error which will occur. So these are my values in my array. Okay. Now we'll also print the original array. So let me give print /n original array. This is your array here. And let us apply the reciprocal function. It is again a part of your NP object. So when we give the function, you have to give NP dot reciprocal and pass the array as the parameter. So let me write reciprocal. I'll just put reciprocal here and directly will print it out. So NP dot reciprocal. This is the function you can see here, this one, and it takes a parameter A. A is my array. Okay. Now here you can see, now if you look at the values for 0.25, I got the answer as 4. For 1.33, the reciprocal gave me 0.7518791. 1 remained 1. As soon as it encountered 0, I got a error here. Okay. As I told you, divide by 0 or overflow error will occur. Whereas if I remove the 0 now, let me remove this. So when I run this now, there's no error, and these are my outputs. Clear? It's a very simple function. So instead of going and doing some other calculation, you can make use of the inbuilt function reciprocal. Now, if I can also have a constant, let us say, I'll take one more example. If suppose I have an integer, say b equal to np dot array, and let us have one area of, say, only one element here, 100. Okay, and I'd specify the d type. Now, in the previous example, when we created the original array, now the type was a float type. Now, if I change this to, say, integer, say d type equal to n. Okay. Now, for 100, you were getting the answer 0.01. That was the answer. Let us see whether we get the same answer again. Let me print b, and then the reciprocal of b. So print b and this np reciprocal b. Here we go. So let's run this one. Fine. So here we got 0. That is what I meant when I said for absolute value larger than 1, the result is always 0. Okay. And provided it is integer, because while performing integer division, I'll get only the integer part. I won't get the float part. Whereas in the previous example, when we saw the same value, we had 100 here, but this was considered to be a float value. And that's why I got the answer as 0.01. Okay. So that's the difference between your reciprocal of a float value and your integer value. Now, the next function which I'll show you is the power function. So let me mark this whole thing as command and up here. Now, for this power function, I'll take one more array, or we can, without an array also, I can show you an example, but let us take an array here. And let me have values like 10, 100, and say 1,000. Okay, so it's a 1D array with 3 values in it. I can print the value of A, the original array, and let us keep another array of say B and to the array, and here I'll put the powers. So the powers will be 1, say 1, 2, and 3. Okay, so the first number, that is 10. 10 will be raised to the power 1, 100 to the power 2, and 1000 to the power 3. That is what I'm trying to do now. So while I give the function, let us give the print function first. I'll say applying the power function on A. Okay. So to get the function is simple, the word np.power. It takes 2 parameters. The first parameter is the number, and the second one is to the power of whatever you want to. I'll just take a simple one right now. Let us say I want to find 5 to the power, say 8. I can pass it like this, and I can run it. So here you get the answer, right? And if I want to perform it for the whole array, then I can give the example A and comma B. So it will take the first element from A, that is 10, to the power 1. From 1 will come from the second array, the first value. 100 will be raised to the power 2, and 1000 to the power 3. Okay, and we can see the answer. So these are your answers. So you can see the resultant array is having the power. So 10 to the power 1 is 10. Then 100 to the power 2, square of 100, 10,000. And then this is the value, the cube of 1000. Clear? So power can either you can apply it on array. We can also pass 2 arrays here. Like in this example, we took A and B. Or you can take some constant values or simple variables and also find out the power of the given numbers. Okay, depending on what you want to do. The next example will be of the function called mod. If you remember the modulus function, your integer division gives me the integer part of your division. If I want to find the remainder of my division, then I can make use of the mod function. It returns the remainder of the division of the corresponding elements in the input array or the number whichever. Of course, we'll be taking an example along with the array. So let us create 2 arrays here. Again, I will use A equal to B dot array. And I'll take only 3 values, say 10, 20, and 30. Okay, so I have an array A with the 3 values. I'll create another array B. So I'll be dividing A divided by B. Okay, and I'll be using the mod function to get me the remainder. So D equal to, let us take np dot array square bracket. Let us put say 3, 5, and let's put 7. Okay, so the first array, let us print both of the arrays, print A, comma, B. Okay, so I'll run this one, and here are my two arrays. And let us find out the remainder. So /n applying mod function. So after applying mod function, I can give print into bracket np dot mod. Mod is my function. It takes the two parameters. The first value is from array A, and I want to perform the division using the values in B. Okay, and it should perform the division and give me the remainders. Let us check it out. Fine. So here you can see when I divide 10 by 3, so the remainder comes as 1. For 20 divided by 5, there's no remainder. And the last one, where we are dividing 30 by 7, the remainder is coming 2. Okay. Now there's one more way of getting the remainders. There's a function called remainder function. So if I want, I can also apply that function to get the remainders. So let us see one more example or statement applying the remainder function. Now the output, we can say print into bracket np dot remainder into round brackets. We pass the two arrays, so A, comma, B. Yeah. See the output. Here you can see. So both the functions will give me the remainder of the corresponding element from the input array. Okay. You can also, instead of array, if I want, I can also give simple values. Like I can give print into bracket, say np dot mod into bracket. Let us pass the two numbers. Say I give 34, comma, let us pass a 7. Okay, so this gives me 6 as the remainder. Okay, there's something in the chat. What if the number of the elements in the array are different? Then it will give me an error. Okay, usually what happens, the number of values should be the same. Clear? And if I want to perform individual numbers, I can do it like this. Clear? And there is way of handling other things, as I told you in previous case also. If there are many, you can say values, and I want to perform the division. Let us say I do it this way, as you said, if I have only 3 and 5. Okay, so here you can see this an error here. Right? It cannot be broadcasted depending on the division. So this is not possible. You can have a single number and you can perform the division, and if you want to find out the remainder, you can make use of combination of groups and all and do the required operation. Clear? So either you apply it on the array, or you can also pass constant values, which will give me the remainder. So either you make use of the function mod or the remainder function. Okay. Now there are some few other functions. The first function is the real function. Now the real function will return the real part of the complex data type. Okay, the real part means the initial part and not the special part. So there are 4 different types of function, which I'll show you in one of the examples here. So let me create another file and input numpy. Okay. Now in this function, there are 4 functions. In this example, there are 4 functions which I'll be showing you. The first one is the real function, which as I told you, will return the real part of the complex data type. Then there's a function called image, without a E, imag, which returns the imaginary part of the complex data type. Okay, the other part. So the real part can be displayed using real function, and the imaginary part will come through the function imag. Okay, there's no E there. Okay, we can also return the conjugate of the complex number. So complex conjugate can be returned using a function conj, okay, which is obtained by changing the sign of the imaginary part. Then the last function which I'll show you is the angle function, which returns the angle of the complex argument. Now, the function has degree parameters here. And if true, the angle in the degree is returned. Otherwise, the angle is in radian form. Okay. So let us take a small example here. I'll create again an array A with some values, the complex values. So we have array into round bracket. I'll put the values, the negative and the positive values. So let us put -5. And if you remember the format of complex value, it has a j in it. Okay, so I can give 5.6 j. Okay, your 0.6 j is your imaginary part. Then 0.2, put a positive value. We can also have, say, only a number. Let us put 11. And I can put one more value, one, say, plus 1j. Okay, this is another form of your complex number. Okay, now we'll also display the function. So let me do that. I print the array A. Let us check whether this is displaying properly. If there's any problem, I'll get it out here. Okay. Now here you can see we have got all the values now. So we got these values here. Okay, all the values have been displayed from here. Now let us try to get the real part from the function. So I'll give print into round brackets. Let us give a string first. Applying real function. So this is my real function. Okay. Just 1 minute, guys. Fine. So here we go. Print into round brackets. I can give np dot real in the round bracket, pass a as the parameter. Let us see the answer for this. Now here you go. The real part of your answer is coming as -0, then 0, 11, and 1. Okay. So you can see this, the values which I had passed, -5.6j is considered as your imaginary part, okay, and not as the real value. And that's why when we displayed the values on the screen, here you got this -0 point and you got -5.6j, okay, and so on. Now only for this 11 point, where we did not specify the j or the imaginary part, it was added on its own. So I got plus 0.g. Let us display the imaginary part. Now to display the imaginary part, we can make use of the function inag. G, after G there is no E there. Okay, so print applying imag function to get the imaginary part of the complex number. So print into bracket np dot imag into bracket a. Okay, and we can run this, and here you can see the imaginary part. So -5.6, this is your imaginary part, then 0.2 and 0 because here I did not mention it, and 1, okay, because I have mentioned this 1j here. You can see this one is your imaginary part. Clear? Let us see some more function. The next function is your conjugate function, and it is used using conj. It returns the complex conjugate, which is obtained by changing the sign of the imaginary part. Okay, so when I display this, what will happen? Your minus sign, which was minus in the first one I had given, minus 5.6j, will now become plus 5.6j, and your positive will become negative. Okay, that's the use or the change which we'll get. So I'll print this again, print, applying conj, this is conjugate function. So I get print np dot conj into bracket a. Okay, so you can just compare this number or the values which the previous one. Here you can see what happened to this now. A is minus 5.6. So here you can see this. Okay, yeah. So this one you can see this is changed to plus now instead of minus. Okay. Again here, my imaginary part has changed from positive to negative. And here from positive to negative again. And again this one from positive to negative. Okay. And the last function is your angle function. As I told you, either you'll get the function, either if we pass the degree parameter, you'll get the angle in degree. Otherwise, I'll get it in radians. So for this, let us create one area, or we can use the same one. Let us use same values. I'll just give a print slash n applying angle function. Okay, I'll put a volume. Now, there are two ways of doing. Either I can mention degree, or if by default it will take it as radian. So here, if I give print into bracket np dot angle round bracket a, okay, where I'm not mentioning whether the degree is true or false. There are actually two parameters. The first parameter is the array, the complex number, or the sequence of complex numbers, which we already have in A. So I can mention that here. Now when I run this, I'll get the radian values. Okay, so this is my radian values of the given, you can say, complex numbers. And if I want the degree values, then I can give print np dot angle into round brackets. Again, the first parameter is your array with complex values. And I can mention degree equal to true. It is a Boolean value, whether you can mention it true or false. Now what will happen is I'll get the values in degrees. Okay. So the first one you can see I got minus 90, then I got 90, 0 remains 0, and the last one I got as 45 degree. Clear? So using this complex values, I can also, using the angle function, I can display the values, the complex values into radian or in degree form as well. Okay, let us move further to statistical functions. Okay, NumPys will support some useful statistical functions like the common ones like minimum, maximum, percentile, standard deviation, variance. These are some common functions of your statistics which are supported by NumPy as well. So let us quickly take some examples. Let me create another file here. So import NumPy as input. Okay, the first example we'll take is of minimum function. Okay, the function which is available here is a mean. So for that, again, I'll create an array a equal to, let us say, np dot array round brackets. We'll create a 2D array here because I would like to show you how to find out the minimum value across axes as well. So whether 0 axis or axis 1, both ways, or the whole array also. So when I do not pass the parameter for axis, it is going to flatten my array and return the minimum value. So let us put some numbers here, 3, say 7, and put 5. So this is my first row, the second row, 8, say 4, 3, and the last one, I'll put 2, 4, and say 9. Okay, so this is my 2D array. Let us print this array. And what I'll run this, this is my array, here it is. Okay. So the first function which we'll use is the min function, a min. So I'll just write here /n a min, and let us see what it returns. I can give print into bracket np dot a min round brackets and the array. Now when I'm passing the array, I can also pass the axis. Let us pass 1 here and check the function, what it returns. So when I run this, here you can see. So what is happening in my first array, you can see 3, 7, and 5. Minimum value is 3. So I get this first 3 here. In the second row again, the minimum value is 3. So I'm getting 3. And in the third row, the minimum value is 2. Now, if I do not specify this, whether it is, I give only A. Okay, so from the whole array, I get the minimum value. Okay, so what it does is, it will flatten my 2D array, multi-dimensional array into a 1D array and search for the minimum value. So either I pass 1 is row-wise, axis 1. If I give 0, that will be column-wise. So let us run this as well. Okay, here you can see now, this is checking one column at a time. So in my first column, minimum value is 2. In the second column, the minimum value is 4. And in the third one, it is 3. Okay. Now, similarly, if I want to find the maximum of the array, I can change this to the max function. The function is a max. Okay. So first one, I'm passing 0 here. So the column maximum values will be displayed. So in the first column, 8 is the maximum value, then 7, and then 9. Okay. If I want to find it row-wise, I can change this to 1. Run this. This is row-wise. In the first row, 7, second row, 8, and third row, 9. Okay. And if I do not pass this axis value, I pass only the array, I get the maximum in the 2D array. Okay, again, while doing the calculation or performing this operation, A max, where I'm passing only the array, it is going to flatten my array and then perform the operation. Clear? This is another way of giving it. If I want, I can also specify, instead of giving only 0, 1, and 2, I can mention axis equal to 0 or 1. So even this is another way of writing it out. So either you can give 0 directly there as a part of the second parameter, which will indicate that it's a parameter for axis, nothing else. Or if you want, you can specify axis equal to 0 or 1, depending on the dimension of your array. If it is a 3-dimension array, then you can also pass 2 as the axis value. Okay, so these are two basic functions. Let us go ahead and see some function which is a percentile function. Or before that, let us see another function called PTP. Okay, it returns the range, which is max minus minimum, the maximum value minus minimum value of values along the given axis. So if I have the same array here, and instead of this, let us say applying PTP. This is the function PTP function, which gives me the value. It returns the value maximum minus the minimum value. So if I apply it here directly, let us delete this. So np dot PTP into round brackets, I pass A. Okay, let us run this one. Now here in this case, I'm not passing the axis value, only the array value. Okay, so I get 7 as the answer. Now look at the minimum value and the maximum value in my array. My minimum value is 2 and maximum value is 9. So 9 minus 2 gives you 7. That is how it is returning here. Now if I specify the axes, let us say for axis 1, so I can give a comma here and specify the axis. Axis equal to say 1. 1, as I told you, will be across the row. So when I run this now in the first one, the minimum value is 3 and maximum is 7. So 7 minus 3 will give me 4. Here 3 and 8. So 8 minus 3 gives me 5. Your minimum is 2 and maximum is 9. So 9 minus 2 will give me 7. And similarly, if I change the axis to 0, it will perform the same operation across the columns. Okay, so change this to 0 and you get the answer here. So we get this 8 minus 2 gives me 6, then 7 minus 4 gives me 3, and finally 9 minus 3 will give me 6. Okay, that is how you get the differences. So if we want to find out the difference between the minimum, the maximum and the minimum value in your array, you can make use of this function PTP. Okay. Now the other common functions are like your mean and median. So let us quickly do that. Let us create an array first. So instead of this, I'll make some changes in these values. Let me change this. So again, I'll have a 2D array only. I'll have say 65, say 70. This is my first array. Next in this, I'll have 70, 80. Let's push 95, 10. Okay, and the last number, let's put 50. We don't have 90 here, so I'll put 90 and 60. Okay, this one square bracket and the round brackets. Fine. So I'll just run this one. Whether I get to this, fine. Okay. And instead of now applying the PPD, let us apply the median function. You know that median is defined as it returns the value separating the higher half of the data sample. So if this is my data sample, it will give me a value which is separating the higher half of the data sample from the lower half. Okay, the median part. So there are two, you can say, levels, the higher level and the lower level. Okay, let us come here. The function will be np.median, okay, into round brackets, the array. Here we can also again specify the axes as well. And when I do not specify, it will consider it as a 1D array. It is going to flatten the array and give me the answer. Okay, so 65 in this example is my median. Okay, I can also pass the axes. So if I want across columns, I can give axis equal to 0. And if I want it across the row, I can pass it as 1. Okay, so this is the median across the columns. So if you look at this 50 is the answer. Here we have 90, and in this case we have 60. Okay, if I change this to 1, this will be across the rows. Okay, so across the rows you can see this 65. Then between this we have 80 here and 60. Okay, this is a very simple function like median. We can have the other function called mean, and you know that mean is nothing but your arithmetic mean, in which the sum of all the elements along that axis, if I do not specify the axis, the whole array will be divided by the number of elements. Okay, that is how we do the calculation for mean. So if I want to find the mean here, I can just give print, say applying mean function. And NP dot mean into bracket A. Okay, here if I specify A here, it will consider the whole array as 1D array and give me the mean of this. So mean in this particular array is 61.66666. Okay, now this if I want, I can pass the axis. So across the column, if I want, I can pass axis equal to 0. Okay, I'll get it for each of the columns. Okay, and if it is 1 across the row, I'll get the other answers. Clear? So your mode function can also be used. So median, mean, max, min. Then we saw PTP. There's a average function which can be seen here. Let us take a simple example of average. Now there are two ways I can return. Either I can have a weighted average. Weighted average means we need to have the weighted values as well for each of the element of the array. So if I take an example, let us take an example here. Let me create an array again. So I'll mark this as comments. Let us create a very simple array. Let us say A equal to NP dot array into bracket. I'll create a 1D array 1, 2, 3, and 4. Okay, and I'll create another one, the weighted values. So for weighted values, I'll write as NP dot array into bracket. Let us put the opposite way, 4, 3, 2, 1. Okay,